Hello guys, welcome once more to Prep Class Physics class, and my name is Dami. Now in this edition we shall look at most of the questions in this edition are based on density. If you have problem with density or you are not too clear about it, you will get a lot of clarity in this series. Now also I have a question on expansivity, linear expansivity. You will get to see how Jamb treats those topics. Don't forget that if you learn something from this series and you want to get more content from us that will better help you understand physics, click on like button. We have a lot to send to you that will clarify so much for you. Now let's get to number 16. An object of volume 1 meter cube and mass 2 kilogram is totally mass in a liquid of density 1 kilogram per meter cube. Calculate its apparent weight. Now when you hear the word apparent weight, you must first of all know that weight is mass. Okay, weight is a function of mass. That is the first thing you must know. So that means I must first of all use this density to find, the density and the volume to find mass. What you are supposed to do first is to find the second mass, because weight is an interplay of masses. So I will just say weight is equal to mass times what? Acceleration due to gravity, right? Now it was given to me here as 10 meters per second square. So then now turn the formula for density around. Density is equal to mass over volume. That's the meaning of density. Then but mass is now going to become density times volume. So I'll find the mass. Now what's the density? Density, the question is 1 and the volume is 1. So 1 times 1 is 1 kilogram. So the weight is mass times g, right? So the minus the 2 masses. Now we have 2 masses. So you have to subtract the masses from each other. The 2 kilogram minus the 1 kilogram mass, and that'll give you 1 kilogram as your apparent mass, and that will become times 10, and that will become 10 Newton as your apparent weight. Now what I'm saying is that for you to be able to find apparent weight, you must first find apparent mass, and apparent mass is the difference between 2 masses. Okay, now from the I was given 1 mass here as 2 kilograms, but I must use the density formula and the volume to find the second mass, and that gave me 1 kilogram. Density times volume is 1, and that's 1 times 1 is 1, and that's 1 kilogram. Then if you now subtract the masses, you will get 1, and then that one mass is your apparent mass, and that's what you have here, 1, and that 1 kilogram is your apparent mass. Now multiply it by 10, and that will give you 10 Newton, and that is your apparent weight, and that is the answer for number 16. Now number 17 says the pressure at any point in a liquid at rest depends on the word. Now when you hear the word pressure and you are hearing depth, now it depends on what? Now when you hear the word pressure, now generally this question is asking you a question on pressure, and this can only be answered by knowing the Pascal's principle on pressure. So if you are a physicist and you say, Mr. Chinedu, can you please tell us what are the factors that affect pressure, or what does pressure depend on? You only have to know what Pascal said, because Pascal is the scientist that made the principle on pressure majorly. Although we can have others like Bernoullis, but majorly in secondary school we were taught only the Pascal's principle. So majorly focus on. So this question is focused on what is the Pascal principle saying on pressure, and that is number 14. Now pressure. Now this is the Pascal's equation, and the Pascal principle spoke about pressure and says that pressure and height are, that means the higher the height, the higher the pressure. So pressure and height are directly proportional, and that is the Pascal principle. And it was from the Pascal principle that we got this equation of pressure. Generally you are taught that pressure is force over area, but for a liquid, for anything liquid, we don't use that formula for pressure. We use pressure in liquid is given by this formula: density times g times a, where my g is my acceleration due to gravity and my h is my height. So pressure is a function of height, and from this formula you can see clearly that pressure is directly proportional to density, to g, and to height. Okay, now that means that the higher the pressure, the higher the density, and the higher the height. They are all directly proportional. So whatever happens to pressure will affect them the same way. Okay, because all of them are directly proportional, and that is what you have there. and that is what you have there. So now let's solve further. So the pressure at any point depends on what? It depends on density, on what? Acceleration due to gravity, and on what? Height or depth. And that is the answer. It depends on depth and density. You know, it is proven by this formula. The formula for pressure in liquid proved it, and that was explained by Pascal, the Pascal principle. So now it is affected by density, acceleration due to gravity, and height, and that is the answer. It is a balloon. Number 18 says a balloon whose volume is 300 meter cube is filled with hydrogen. If the density of air is 1.3 kilogram, that should be per meter cube. Find the up thrust on the balloon. Now we are finding up thrust, right? Now, what is the relationship between up thrust is force. Up thrust is force acting up. Like if you jump inside a river, there will be a force that will take you and take you up. Or else, if you don't get that, if you put a straw inside Fanta or inside any soft drink, as you put in the straw, you push down the straw, but there's a force in that liquid that will push up the straw, and that force is called up thrust. Up thrust is the force that pushes things up, and that's why it is common in water and in air. Majorly in water, it is more obvious in water. So if in fluid, not just water, in fluid. So if you jump inside a fluid, it will push you up. But now, a balloon has this volume and so on. So we are finding the up thrust now. Now, how do you find up thrust? You must know that up thrust is force, like I said before. So first thing to do is to find the mass. Now, density was given and volume was given. So I know that this is a density setup. So I will find the mass. You know, density is mass over volume. So mass is therefore going to become what? Density times volume. And that will become density is 1.3 and the volume is 300. And that will give me 390 grams. And that is the mass. But up thrust is the upward force. And you know that anything force is mass times g. That means force is always mass times acceleration or acceleration due to gravity. So now the mass here is 390. So my up thrust will now become mass times g, and that will become 390 times 10, and that will become 3,900 Newton, and that is the end for finding up thrust. Remember, I came from the density formula to find the mass, and I multiply it by g. That's acceleration due to gravity. That's 10, and I got my force, which is my up thrust, and that is just it. So that's number 18. The answer is C. Number 19. Clinical thermometer are examples of what? Now this is very easy. The thermometer that we use in the clinic, is this pressure gas thermometer? Do you see gas coming out from the thermometer, or is this resistant thermometer? Is this alcohol thermometer or mercury in glass? Do you have any idea? This is very easy. Now that is correct. The answer is just mercury in glass thermometer. Now you can see this is actually mercury in it. So they can put it in your tongue, under your tongue, to check your temperature, or put it in your armpit, or if you are a baby, they will put it in your butt, and that is the way they check your temperature in the clinic. But the thermometer is a mercury thermometer because mercury is the best and the easiest. Because mercury is not difficult to read, unlike alcohol. If it is alcohol, it is not clear enough. No, alcohol is like water, so you can't really see the readings. But mercury, because it is colored and it is opaque, it is easy for you to see the readings, and that is just mercury in glass thermometer is the clinical thermometer. So let's see number 20. Two metals P and Q are heated through the same temperature difference. If the ratio of the linear expansivity of P to Q is 2:3 and the ratio of their length is 3:4 respectively, the ratio of the increase in length of P to Q is what? Now the first thing you must do as a physicist is this. You must first write down the linear expansivity formula, and that is linear expansivity is called change in length over length times change in temperature, right? Now we are finding the ratio of increase. No, increase in length is our focus now. So solve for increase in length. So if I make increase in length, that's change in length, the subject, it will become change in length. That's change in length equals linear expansivity will cross multiply. If I cross multiply, this change in length will come here, and the linear expansivity will come and multiply this. That will become linear expansivity times length times change in temperature, and that will give me, substitute in, because I don't have temperature in the question, so that will become, it will become a constant, and that means it is out. So I'll focus on, I have the ratio for linear expansivity that as 2:3, that's 2/3. Then the ratio for length is 3:4, which is 3/4. So multiplying the two of them, that will give me 2/4, because that will give me 3 cancel 3, that will give me 2/4, and that is my change in length. Break it down. If you break it down, that will give you 1/2, and that will give you 1:2, and that is the answer for the increase in length ratio. So the ratio is 1/2, or in ratio form that will become 1:2, and that is the answer for number 20. And that brings us to A as the correct answer. Please don't forget that everything came from the linear expansivity formula. Linear expansivity is change in length over length times change in temperature. If you make change in length the subject, you'll be getting, if you multiply, that will be change in length equals linear expansivity times length times change in temperature, and that will give me linear expansivity as 2/3 and length is 3/4 times 1, and that will give me, if you cut 3/3, you get 2/4, which is 1/2. When you cut it further, and that will give you 1:2 in ratio form, and that is your answer there. Now that brings us to the end of this video. Don't forget that if you learned something from this video and you want to get more content that will better help you simplify physics, click on the like button and we'll get to reach you with more content that will explain so much to you. Until we see you again, guys, take care of yourself and bye for now.